So your mom has given you an assignment where you are asked to make a mango milkshake for her. And if we were to talk about milkshake, of course we need to make a mango milkshake. So what do we do, or what do you do? Well, you first pour in your mangoes, right? You pour in your mangoes. Well, first things first, you've done your first task. Congratulations. And then you pour your milk. Am I right? Well, absolutely. Absolutely. So you do your first task quite well, but that's not a mango yet, because you've that's not a mango milkshake yet, because you've just poured your mangoes and your milk and you have it, blend it up. And when you blend it, so what do you get is that you get your favorite mango milkshake. Okay? So that's what you get. Well, that's not all, right? So if I were to, contemplate on my inputs and my outputs, well, what were my inputs? So my inputs were simply milk, mangoes. And what were my outputs, or what is my output? And my output is simply mango milkshake, right? So I can say this machine converted my mangoes and my milk to mango milkshake. In other words, I can say that this machine performed a function. Well, in context of this scenario, what is a function? Well, function is any machine. Function is basically a machine which converts your inputs to outputs. A machine where your inputs are converted to outputs. And in this case, my milk and my mangoes were converted into the mango milkshake. All right. So my inputs are milk and mangoes, and my output is, simply mango milkshake. If we were to apply a little bit of algebra onto it, I can say, or I've been given a function where function, which is denoted by f of x, which means function of x, right? Function of f. So x is basically my input. All right. So x is my input, and any value of x is my input. X could be 3, 4, 3, 4, or etc., etc., etc. It could be anything. It could be an odd number. It could be an even number. It could be an integer, a negative integer. It could be anything. It could be a fraction. It could be anything. So x is basically my input, and my input could be anything. Similar to a juicer blender machine, simply just like a machine. Your input could be anything. All right, it could be anything. And so, given to the domain, my input could be anything, and well, x could be 3, 4, or anything. So, what does f of x mean? It means my function, my f is my machine. Well, this whole lot is my machine, right? That's my machine where my x is the input, and then my answer comes out to be the output, and that's my answer. Okay, so my answer is my output. So similarly, f of x is equals to x squared minus 2x, x cubed minus 2x. All right, and what does f of 11 means? Well, it means that in place of x, I've used my value of 11. My x is equals to 11. X is my input, and my input is equal to 11. So it means 11 is my input. It is the value of x. So it means I will plug my 11 value, the value of 11, wherever my x exists or is placed. So 11 cube minus 2 into 11, and I've substituted, and my answer comes out to be 1309. Similarly, f of 20. Okay, well, it means my x value, x is equals to 20. My input, which is my x, that is equals to 20. So in my machine of f, I've placed my input x, which is equals to 20. All right. So f of x is equals to x cubed minus 2x, and for f of 20, well, it simply means 20 cube minus 2 times 20, that comes out to be 7960. All right. For example, let's take at another look. G of x is equals to, or it is given as 4x to the power of 5 plus 5x cubed plus 2x squared. All right. So basically, it means that my machine is G and my input is X. All right. So my machine is G and my input is X. And I've been asked to calculate G of 5. It basically means that in my machine of G, I'm going to put my input of 5. My input is 5. My input, which is equals to X, X is equals to 5. And so wherever I see my X, I will just plug in my value of 5 there. So my input, which is X, is equals to 5. And now I'm going to place 5 wherever is my X. So it looks a lot like this. So my equation comes out to be like this, and that is equals to 13175. All right. So if I were to calculate G of 15, well, again, my G of X is equals to 4x to the power of 5 plus 5x cubed plus 2x squared. Okay. So it basically means I'm going to plug in my values and value of 15 wherever is my x plus 5 into 15 to the power of 3 plus 2 into 15 to the power of square to the power of 2. That comes out to be a lot big number, and I can't even pronounce it if I were to be truthful. So what do we learn? We learned that our machines are denoted by g of x, f of x. It could also be g of y, okay, where my g means my machine and my input is y, okay. So it could be g of a, it could be g of 6, it could be any number. It could be m to the power of, well, m bracket k. It basically means my machine is m and my input is k. All right. So whatever the values of k will be plugged here, and we can calculate our outputs. So these values, my answer, my final answers, those are my outputs to the inputs of 5 and 15 respectively. Okay. So let's take at another look here, or I should make another thing here. Okay. So well, let's take at another look. Let's take another look. So my mother asked me to, just make some chocolate here. And because some guests have arrived and they enjoy some liquid chocolate, who doesn't enjoy liquid chocolate? So my input is chocolate. Well, that's solid chocolate, okay? My input is solid chocolate. And my output is simply liquid chocolate, okay? That's my output. So my output is simply solid chocolate, liquid chocolate, and my input is solid chocolate. But there's a pattern here. There's a little bit of a thing here, and that is, if we were to, focus on this only, if we were to only focus on this, there's a little bit of a difference here, and that is, both of these things are only one. What I mean to say is, my input is only one input, and my output is also one. So what does that mean? It means my one input gives one output, one in is gives one output. Okay. So one in goes or gives me one output, or I can also say that it is a one-to-one function, because my machine only gives one output when I plug in one input. And in our above case, in our previous case, or in our first case, I can see that my two inputs, there were two, milk and mangoes, they gave me a single output. So I can say that these are two to one function, or I can say they are many to one function, because many of my inputs only gave a single output. It only gave me a single output. Milk and mangoes, well, they are considered a plural, and I can say that they are basically two inputs or many inputs, and they give me a single output of mango milkshake. So that's a many to one function. And I really hope I've cleared all of your doubts and cleared all of your things. So yeah.